Okay, here we go for our final lesson from graphing. This is only, of all the courses that are in this section, this is only covered in Math 053, the stuff we're going to talk about right now. So let's take a look. So a quick reminder to start. So here's what we did on our last lesson. We discovered that if we isolate the y in an equation, and then we can just read the slope and the y-intercept right off of it. The slope is the number in front of the x, and the y-intercept is the number added or subtracted at the end. Yeah, and we use the letter m for slope and b for y-intercept. So very, very quickly, this is a review of what we did last time. Here's some lines. Let's read off the slope and the y-intercept. So the slope, number in front of x in blue there, is 3/4, and the y-intercept, did it backwards, the y-intercept, the number at the end, is -5. So give those two a try yourself, and then we'll do them together. Give you 30 seconds. All right, so this next one, double check that is the y is isolated. Yes, it is. So we can just look at that and see the slope is the number in front of x, and the y-intercept is the number at the end. So the y-intercept is +3. The slope is -2, which, because we always want to think of slope as a fraction, we might just write -2, but we do remember that actually means -2/1, down 2/1, rise and run. Last one, is y isolated? No, it's not. Very common for people to say the y-intercept is 24 and the slope is 2 on this one, because that kind of follows the other pattern, but remember that pattern only works if the y is isolated. So I take that. I remember that the 2x and the 24 both have a plus in front of them, even if I don't bother to write it. I subtract that 2x over to the right, remembering that what I really just did is subtract 2x from both sides. Divide everything by -6 because they cancel on the left, which gets the y by itself, which is the whole point. -2 over -6, reduce that fraction, is +1/3. And 24 divided by -6 is -4. So now we have y equals, so we can just read off the y-intercept is down 4, -4, and the slope is 1/3, rise 1, run 3. By the way, just sort of to keep things simple, you will pretty well always notice that your y-intercepts are tending to be whole numbers. There's no reason they have to be, though. We're just sort of keeping things simple. So if you run into one and this back here, the y-intercept is a fraction, no big deal. You know, if it's a fraction, that's fine. The y-intercept can be a fraction. Where that becomes a problem is if you want to graph the line. Then having a fraction y-intercept is going to be a problem. But that's okay as well, because remember, we have a bunch of other different methods, including just fishing around and finding two xy points on a table of values that makes the equation true, right? So the y-intercept can be a fraction when it is. We don't want to graph it that way, but that doesn't mean you can't find the y-intercept and answer the question that says, what is the y-intercept, even if it's a fraction. We're also remind ourselves that last time we saw that with this information, right, looking at that equation, reading off the y-intercept and the slope, gives us a really easy method to graph when it's in that form. First, we plot the y-intercept, which in this case is -5, so 5 down, right there. And then from that point, rise 3, run 4. We're going to end up over there. I think I'm going to change the colors first. Yeah, there we go. So we're going to rise 3, run 4, put on a new point. We now have 2 points on the line. If you're doing this by hand, you pick up a ruler and join them together. If you're doing this with a graphing utility, you probably put those 2 points there and it just automatically draws the line through them, like so. Okay, so what we are going to do in this lesson is we're going to turn this right around. Instead of them giving us the equation of the line and we use that to find the slope and the y-intercept or to draw the graph or to answer whatever other questions they might ask, we are going to be given some partial information about a line, and then we are going to find the equation ourselves, right? So backwards, before we were being given the equation on all of the questions, now we are looking at finding the equation after being told something about the line. We know that y equals mx plus b is the equation of the line. So this first scenario here is the easiest one of all. So if we are given the slope and the y-intercept. So for example, what is the equation of a line that has a slope of -5 and a y-intercept of 7? Well, that's everything we need, right? The slope is -5, the y-intercept is 7. There, we got that information. We know that y equals mx plus b is the equation. So we just pop the -5 in for the m and the +7 in for the b, and we are off to the races. There is the equation of that line that they described to us, right? We could have also drawn this line. We could have drawn the line with the y-intercept of 7 and a slope of -5, but they didn't ask us to. They asked us to simply find the equation. And so since we know m and we know b, that's easy. Now, watch out, because sometimes they can give you the slope and the y-intercept, but they do it in a bit of a sneaky way. So take a look at this question. Let you read through that and think about that for a second. So the equation of a line that passes through 0, -2, and is parallel to this other line over here, y equals -3/5 x plus 4. What does passes through 0, -2 mean? Well, that means the line goes through that point right there. And that point right there is right on the y-axis, so that is actually going to be the y-intercept. B is -2. So they didn't tell you the y-intercept is -2 or b is -2. Instead, they said the line passes through 0, -2, but it's the same thing. That is the y-intercept if the line goes through that point. What about the other piece of information? What does parallel to this line here, what does that mean? What do parallel lines have in common? They have the same slope. So that means if the line we're looking for is parallel to this one, then it must also have a slope. I can't highlight it. No, won't let me do it. It must also have a slope of -3/5. So they actually told us the y-intercept and the slope, which we can just plug right in. Y equals -3/5 x minus 2, like so. Okay, so they told us the y-intercept and the slope. They just did it in a bit of a sneaky way. And that's your answer. I would like to take a look at this because there's a common thing that bothers students that I want to explain here. So there is the blue line that they told us the line we want is parallel to, right? A y-intercept of 4, and from that point down 3/5, rise and run. And here is the answer that we got, which we're going to graph in red. So you can see that we did indeed get a line that has a y-intercept of -2 and is parallel to that blue line. We got exactly what we wanted, right? The answer we got is exactly the line that was described. What a lot of students will ask here is they'll say, wait, what about the +4 though? Because we didn't use that at all. And you're right, we didn't use it all because the +4 is where this blue line crosses the y-axis. That has nothing to do with the red line that we wanted to find, right? If there's any hockey fans in here, you're hearing me talking about the red line and the blue line, you probably want to go watch the game. So all we needed from this line is the fact that the slope is -3/5, which means the slope of our answer is the same because we've been told our answer is parallel to it, right? We do not care where this other line crosses the y-axis. It's completely irrelevant. We care where our line crosses the y-axis, which is at -2. Okay? Yeah, the +4 has nothing to do with the line we want. So all we get out of that blue line is the slope. All right, this is going to step up in difficulty a little here now. So now instead of just being given the slope and the y-intercept, instead they're going to give us the slope and a point on the line. And there is several ways to do this, one of which is quite a bit longer and causes a lot more confusion. So I'm going to go straight to the simplest way to do this, and that is to use a special version of the equation of a line. And there it is. And we are going to do an example first so you see how it works, and then I'll very quickly show you where that came from. So where m is the slope and x1, y1 is any point on the line. So you have been given the slope and you've been given a point on the line, which is exactly what we're saying up here, right? Given the slope and a point on the line. If you know the slope and you know a point on the line, you can plug into this little equation right here and then just do a little bit of simplifying, and you will get the answer. And again, I'll show you really quickly where it comes from after we've done an example. Most of you, I'm going to say all of you, I allow to have a handwritten resource sheet on your tests. I would put this on it for sure for this chapter, and remind yourself even with a little sentence of when to use it if you want to. So we're going to give this a try, and then we'll look at where it came from. So find the equation of a line with a slope of 2 that passes through the point 6, 1. So you notice we've been given the slope and we've been given a point. And I've color-coded everything there so you can see when I put it in. But slope, identify the point, and you say, oh, I know the slope and a point. I can use my special little shortcut equation. And we're simply going to put all those numbers in, right? There's the color coding matching. So I put the 1 in for y1, the 6 in for x1, and the 2 in for m, like so. And if you want to get really technical, that is the equation of this line. However, what they generally want you to do, and what I would always do to be safe, is they want you to put it into y equals form. So to do that, I'm going to expand that bracket on the right, 2 times x and 2 times negative 6. So that gives you 2x minus 12. Then I'm going to add this minus 1 over to the right, like so, getting y equals 2x minus 11. Now, if we were to graph y equals 2x minus 11, I probably should have done this. If we were to graph that now, using our new graphing method, you would see that it does have a slope of 2, and it does pass through. One of the many billions of points it passes through is indeed the point 6, 1. Okay? So I think I promised you very quickly where this formula comes from. Do not worry if you don't quite follow this. You don't need to reproduce this. You don't need to know this. You just need to know how to use the equation like we just did. But I sort of believe just in general in not just giving people a magic formula and not telling them where it came from. So we start with the slope equation, which you've used a whole bunch so far. And now we're going to do something a little bit ingenious. So we remember that this is for any 2 points on the line, right? x1, y1 and x2, y2 are both have to be points on the line, and then this will give you the slope of that line. Normally, those are 2 points that you know, and then you plug all the numbers in and calculate the slope. But imagine if instead that second point, x2, y2, instead of being a point you know on the line, imagine that was a point you don't know on the line, xy. Some xy, any xy that's on the line. And you put that in. And then we're going to multiply both sides by that denominator, like so, because then it can cancel. And just like that, we have the special equation that we came up with. And the way we built this is that x1, y1 is a point that you know on the line, and xy is any other point on the line, right? A point on the line that you don't know. Well, that's every other point on the line, right? So that's why this little shortcut equation works. It just comes right out of the slope equation, and with the insertion of an unknown point as one of the 2 points. So let's try another one, because they will get a little more difficult when you're expanding those brackets. You're often going to run into fractions. So find the equation of the line with a slope of 2/3 passing through the point negative 12, 4. So slope of negative 2/3, passing through negative 12, 4. So we know the slope and we know a point. Aha, you say, I know the slope and I know a point. I can use my special little shortcut equation. And again, I simply pop the matching numbers in. 2/3 for m, negative 12 for x1, and positive 4 for y1. You see over on the right here, we are going to have x minus negative, so we know that becomes x plus 12. Minus a negative is plus. And we are going to have to expand that bracket, and there is fractions involved. So 2/3 times x is 2/3 x. That's not bad. 2/3 times 12, well, we need to make that 12 over 1 in order to do the fraction work. And we could go 2 times 12 is 24 and then divide by 3 and get 8. In this case, that wouldn't be so bad, but remember, sometimes the numbers can get a lot bigger, so let's instead keep practicing our canceling. When fractions are being multiplied, that 12 over 3 can reduce to 4 over 1. Well, that's a lot easier. 2 times 4 is 8. Now I add 4 to both sides. So minus 4 on the left becomes plus 4 on the right, and I just added it right into that 8 to get 12. And I apologize for those watching the recording. I know sometimes the toolbar along the bottom blocks off the bottom of the screen. So if you can't see that, I'm sorry. It says y equals 2/3 x plus 12. And oh yeah, I did put it over there so you can see it. There's the final answer, 2/3 x plus 12. Okay, so plug in your slope, plug in your point, and expand the bracket and solve for y. Scenario number 3, given 2 points. This is actually identical to scenario 2, with one change. We don't know the slope, so we have to find it ourselves, right? Can we find the slope with 2 points? Yes, we can, by using the slope formula. So find the equation of the line passing through 2, negative 3, and 4, 2. So there's 2 points. You don't have the slope and a point, so you can't use the slope point formula yet, but you can find the slope yourself. So there's all our numbers to go into the slope equation, like so. y2 minus y1 over x2 minus x1. 2 minus negative 3 is 5, and 4 minus 2 is 2. 2 minus negative 3, remember, means 2 plus 3. Okay, now we have the slope. We have the slope and a point. In fact, we have the slope and 2 points. Which point should we use? Well, actually, you can use either one of them, and they will both give you the same answer. You think, how could that be? Because they're different. They are different, but they're both on the same line. Once you do all the simplification, you would get the same answer no matter which one you tried. So here, just for simplicity, since I had already labeled this as x1, y1, I'm just going to use the same point. So x1 becomes 2. y1 becomes negative 3, and the slope we calculated ourselves is 5 over 2. And the rest is simplification. Oh yes, we already said this. You can use either point in this step. So we could have used the point 4, 2 as our x1, y1. It would look different in this step, but the final answer, I guarantee, would be the same. You can try it after the lesson if you want on your own to confirm that. So y minus negative 3 becomes y plus 3. 5 over 2 multiplies through the bracket, getting 5 over 2 times x, and 5 over 2 times 2, which I'm going to make 2 over 1, right? And the 2's cancel. That's nice. So y plus 3 on the left equals 5 over 2x minus, this just becomes 5. And then we got to subtract that 3 to the right. Negative 5 minus 3 becomes negative 8. And again, I've tucked that over in the corner, hopefully out of the way of the toolbar. If not, I apologize. Y equals 5 over 2x minus 8. Okay, I think, yeah, we're going to do one more, and you're going to try this one on your own. There's your 2 steps. Okay, so let's give this a try. We want to find the equation of the line, which means, in this case, let's think back through what we talked about. Our first scenario was they just gave us the slope and the y-intercept, and we just plugged into y equals mx plus b, even, easy. Our second scenario was they gave us the slope and a point, and then we used our special slope point formula that you're going to have with you on the test. And now in our third scenario, they give us 2 points, which simply means find the slope on your own and then do it the same as the second type. So there's the slope equation. There's our x1, y1, and our x2, y2. If you find you get confused plugging into the slope equation, just doing this really quickly, labeling up your 2 points, makes such a huge difference. Plug into the slope equation, y2 minus y1, so -3 minus 0 on the top, x2 minus x1 on the bottom, 8 minus -4. -3 minus 0 is -3. 8 plus 4, so that's 12, and that fraction reduces to -1/4. So there's our slope. Now we can use either one of those 2 points along with the slope in our slope point formula. Right there. I tend to try to take the point that looks like it's going to be easier. And in this case, you got that 0 there. Boy, that sure helps, right? Always when you have a 0. So I would definitely use this point in this particular question, but there might be some, one is all negatives and the other is all positives, and that might lead you to use the other point instead. So we're simply going to take our slope and our x1, y1 point and plug it in to that equation. x1 is 0, y1 is I lied. x1 is -4, y1 is 0, and slope is -1/4. So the left side just becomes y. That saved us a bit of work already. Multiply the -1/4 through the bracket. X minus -4 becomes x plus 4 before you multiply. Now multiply the -1/4 through the bracket. -1/4 times x, we just leave it like that. -1/4 times 4, well, that's -1/4 times 4 over 1, and the 4's cancel out. Again, that worked out well for us. So we have -1 over 1, -1. So y equals -1/4 x minus 1 is the equation of the line that passes through those 2 points.